Today's topic is an introduction to data modeling, and specifically the standard called Project Haystack. I'm going to take it right from the very beginning for all of you that have no exposure to it. And then I'm going to kind of build a bit of a background as to what some of the terminology and concepts are behind it. And then more importantly, I'm going to bring it into the real world. You know, we all talk about these big lofty ideas, you know, the cloud, the big data, analytics. And I really, when I go to a conference, want to bring something back with me that's tangible that I could apply and do something with and see that it's making a difference. And this topic, I think, is lofty and is earth-changing or sea-changing, if that's a word. But it also has some real practical applications. And I'll share some of those examples and some references to KMC products that utilize it. So without any further ado, let's get started. Just a quick little history. Anybody recognize one of these? Exactly, the boat anchors. This is a pneumatic panel, and during the preparation for this presentation, I had this epiphany that things haven't really changed that much from a tool standpoint, and you'll see what I mean in just a minute. But effectively, back in the pneumatic era, which is where I got started, my first day on the job, they handed me a roll of tubing and a tubing cutter, and my job was to connect up 500 VAVs at a school project. And they said, we'll see you in 3 months, and that was what I had to work with. And so each one, I cut a piece of tubing, I then fitted it onto the controller, brought it over to the actuator, and so forth. You know the drill. And really the only innovation that I was able to do is at the beginning of my day, I would cut 15 tubes all the same size, so at least I could pick out of my pocket the right size and make all my VAVs the same from that perspective. The next innovation, though, in our industry was going from air as the signal and mechanical means like orifices and springs to make the decision to electrons making the decision. So electronic controls were just balanced bridges of electricity. The tools evolved to copper wire and wire strippers. But the story of the labor that went into it was the same. If I had 5 air handlers, I would make 5 of these control panels. They would all have the controllers inside. They'd all be wired up. The relays would need to be wired, and so on and so forth. And so it slightly evolved, maybe a little bit more accurate. Didn't require much in the form of calibration. But from the standpoint of this presentation, which is about tools and applications, it really didn't change that much at all. Maybe a digital gauge as opposed to an analog gauge on the panel. And then my career really took off when I got into DDC controls. But here's the aha moment that I had when I was doing this. You know, the tool evolved to a computer, or the medium that I was doing my programming in was a computer, and my tool for moving things around and making the parts fit together was a mouse. But the aha moment was that if I had to do this control sequence for this room, chances are really good that I would draw it once, very similar to the wiring and the tubing, and then go and copy it and paste and then link, link, link to get the next one done, and then repeat, rinse, repeat, rinse, and continue that process for all 500 VAVs. And so the promise that computers saved us labor in this tool's context is really not true at all. It's really just a substitution, a virtual version of our control panel. And that's where I see a sea change or a step change about to happen in our industry. Let's enter in now tagging and data modeling for the first time in the discussion, and let's look at it from a tools and an application standpoint. And the idea here is the computer, the tools and the applications are going to do work that we normally would have had to do, the duplication, the linking, the copying, the pasting. And this is exciting stuff because it's not a new concept. It's been used in plenty of parallel universes to building automation. It happens in IT all day long. It happens in social media. It happens in enterprise applications. But here in building automation, that previous slide is kind of the state of the art. And what I'm proposing is we are here today, and this has already happened. We're already 2, 3, 4 years into this standard, and that standard is called Project Haystack. And I'll give you some great resources, but I have it over here on the other screen. It's project-haystack.org. And I won't get into the gory details of it. And in fact, I'm going to stay at a high level just so that you get the gist of the payoffs more importantly than the syntax or some of the gory details. But the point is that the amount of applications and things that we can hook to our smart building are going to go up huge. And the amount of effort it takes to get them connected and get them talking to those applications is going to go down significantly. And the reason that is because we're going to add one little piece of information to our real world, and that's called a tag, or metadata in the most generic sense. And tags are basically a way for a computer to know something about a piece of information. So that's my working definition for today. A tag is a way for a computer, an application, a tool, to know something about a piece of information in the real world. And for the context of HVAC, let's call it a point. Base temperature, discharge temperature, fan command, that kind of thing. And then we'll build up from there. So the challenge is that the world is getting smarter and it is connected, and we've got lots of good things going on with standardized protocols. And customers do see the value of big data, but the problem is that they've been finding it difficult to realize the potential of it. And the dirty little secret in building automation is that lots of different things exist, and they exist over a different time frame by different people. And really all we had to work with, even though we had standardized protocols, is just a simple naming convention. And typically it's not always the same from one person to the next, from one job to the next, from one manufacturer to the next. So even though we have devices at the low level talking, I'll get into a little bit of an architecture in just a minute, the challenge is that we're not really fully tapping that big data because there's a lot of labor that goes into the mapping and the connecting to the data. It's a bigger opportunity and a bigger problem as well, and that is that really these islands of information exist that cross beyond just building automation. The ones that we're familiar with would be this island right here, all the control data. So that's what's out on the BACnet MSTP bus or over on the Modbus meter and what have you. And then of course there's islands of integration. So companies like Tritium and their Niagara integration framework brought these things together. And there's a ton of great data inside of those. There's content in databases. So a customer that's running a facility probably has all his addresses and their streets and even their geolocation for each of the properties for a multi-site retail, as an example. And that is untapped data for us. We typically manually type that in at the beginning of a job, don't we? And the emerging analytics. This is a topic that we heard quite a bit about, and we'll continue to see those rules, and the engine that's processing those rules is a parallel island of information. And my daughter is a environmental biologist, and she specializes in GIS. Anybody know what that is? That's mapping and the data on the maps. Lots of great stuff, particularly the bigger the enterprise, the more important that applies to. So that's kind of the landscape, and what we're going to propose today is that through tagging and a higher concept called data modeling, we're going to be able to break down some of these silos and get to that data in a more efficient and cost-effective way. That's my elevator speech. Now, it's not all bad news either. There's been a lot of great progress. Open protocols have gotten us quite a ways, but not all the way. And so certainly open protocols like BACnet and LawnWorks and Modbus have significantly standardized the device level part of the architecture, and aggregators like Niagara have done a good job at the supervisory level. But unfortunately, that information is still kind of in pockets depending on where you are in the architecture. We can't just go out and get an app and then have it magically go and give me all my energy reports. There's a mapping and there's an engineering effort that goes along with that. Now, I collaborated with our friends at the National Renewable Energy Labs, and they came up with this concept of their view on interoperability, which I think is really, really good, because it tells the story a little bit beyond the technical, which is really the BACnet and the LawnWorks and the field bus device level. And it actually starts to hint at what we're going to talk about today, which is the informational level. And then it really kind of challenges us to look at the bigger picture, which is the organizational level. That would be, for instance, companies with best practices, whether the end user or the system integrator doing the work for them. There's some standards out there for that. So we're going to start right in the middle, and then we'll jump over to the other one. So the Haystack standard, which is what you see over here, projecthaystack.org, is really not too different from BACnet in the sense that it's a bunch of smart people that got together and they said, let's try to standardize what the things that we find in a building automation system are. And in fact, once we have that methodology, it could apply to just about everything. It could be lighting, it could be energy, and it could go beyond that. Interesting enough, though, it is also a protocol. So that parallel to BACnet continues. It's a standard as well as a protocol. And we'll talk about that over here on the technical side. Cool. How many people think Project Haystack is a naming convention? Anybody? Yeah, that's a very common misconception. It's not wrong, but it's not necessarily the root concept that I want to convey. We can work with naming. In fact, the name, or better known as the DIS, display tag, is a legitimate tag inside a database, and we can use it in graphics, we can use it for queries. But the point is there's a bigger overarching metadata concept that if we put a little bit of information on that point, name being 1, discharge temp, and sensor being 2, 3, and 4, now any application can go get that information. And I'll give you some examples. So here we are on the technical side. Like I said, Project Haystack does have an API, application program interface. So anybody that has a cool controller, KMC Commander, or anybody has a cool application sitting in the cloud, KMC Commander Cloud, they could utilize that API in their software, and now they've got a very powerful, high-speed, queryable protocol that can return information in a very fast way and a very concise way. There have been attempts to do that in different markets. So as an example, you'll see OpenADR, OPC, down at the lower levels, Modbus, BACnet. So you're familiar with protocols. I don't need to give you an education. But just rest assured, it's a next generation IP-based protocol. Now, as far as the standard is concerned, this is where we get into the equivalent of naming conventions. So if I were to drill into Project Haystack, look up an air handler, it'll give some suggestions of what people have figured out or collectively come up with for what the different inputs and outputs that you'll find on a typical air handler and what tags to put on those points so that any application could connect to it. And then this last piece is really best practices. And this is where we hope it goes even further, that things like Energy Star Portfolio Manager, ISO 50001, Energy O&M Guide, Operation and Maintenance Guide. These best practices would leverage these standards and would inherently communicate over the Haystack API. So I had an end user here from a college on the previous presentation, and he says, yes, that's exactly where I want to be. I want to be able to pass on my facility to my successor, and I want to have these best practices and that conversation around Haystack and an open standard to be the basis of what I'm passing on. I thought that was pretty cool. All right, so that's really the background high-level stuff. The key takeaway is that Haystack will cover these two today, and we hope to continue the conversation there tomorrow. Yes?
Is it fair to say that Lawnmark was somewhat similar or had their efforts?
Yes, Lawnmark was a little bit more about certifying the device, and the one thing I didn't mention is this spectrum of where we are in the architecture. So in a way, you could say that Lawnmark was right about here, down at the device level, for the standard and for the field bus communication. Excellent analogy. And now as we work our way up the architecture, you'll notice that we've got control, we've got supervisory, and then we have the management level. And so we'll be talking about the standard being able to cross all the way up and down. Interesting enough, the Haystack API, state of the art right now, is about here in the supervisory level. Applications like KMC Commander Cloud would be the management supervisor level if it's a small or medium-sized job. And when it's in the cloud, it would be management. There are other manufacturers that I've been exposed to that are actually bringing device-level data that speak Project Haystack protocol, the Haystack protocol. So it's getting interesting. So as far as this tagging thing, let me give you a real-life example. My day job is really to do marketing for my company at J2 Innovations. And so as an example, I took a picture today of the great food at lunch. And I upload that to our corporate Facebook account. And you know, inside my camera, I'll use the analogy that that file for the image is like a point for an air handler. And so it was generically named image123.jpg. But on the way into Facebook, I added some tags. I did a pound Genius Summit. I did a Langham Hotel. It knew already that it was coming from my smartphone, so it vicariously added that. And the coolest thing happened. There wasn't a system integrator over in Facebook grabbing that file or that point and then putting it on a graphic. It actually showed up on my mobile uploads. It showed up in Teresa's current news feed because she has a friendship relationship inside social media. And it'll show up geo-coordinated. If I ever click on the image, it will show that it was here in Chicago at the Langham. And so the point is that there's an application that leverages tags already out there. There's tons of them actually, and we're just borrowing that concept and trying to apply it in the world that we're sitting. And so what I'll show you is examples of a point and applications that leverage points, like Commander cards, and those will automatically or programmatically take that information and do some really cool stuff with us. And those steps are things that you would have had to do normally today with a mouse and a screen times however many steps that you got to do it. So that's the payoff that I call it. So really all we're doing is taking, let's say, a point name, and in place of trying to decipher that as a human, we're going to add some metadata, which is, in this case, a tag called sensor, a tag called discharge, maybe air. Those descriptive tags will be in the database record while I'm creating it, and there's a lot of neat ways to do that very efficiently. I can also create that relationship like I shared with people that are friends to me, but in this case of building automation, that relationship would be called a reference tag. And so this VAV might get its air from air handler 1. So that relationship we can put in, and there'll be applications like a summary screen that could automatically show, based on a query, which VAVs are associated with which air handler. So let's take this into the real world. So here's an example of 3 database records. So we're getting a little bit technical here, but generically speaking, just think of this as like an Excel spreadsheet. This is one row in the spreadsheet, there's another row, there's another row. It's just a real simple database. And the row is the record, and that record's going to represent something to the applications, to the real world. The tags are just columns, if you want to think of it that way. And what makes this record feel and behave to the applications like a site is because it actually has a marker tag on it called site. What makes this record feel to the applications like a piece of equipment, get this, it has a marker tag called equip on it. And as you're kind of following along with this, why does this record feel like a point to the real world? Because it has a tag on it called point. It's really that simple. Okay? And then we can add extra stuff that is not necessarily mandatory, but I like your LawnWorks profile. Remember, there was mandatory and then optional. We have recommended tags. So if I'm dealing with a site, there might be an area, a weather reference, a city, a state, and a time zone as recommended tags that you could or you don't necessarily have to have filled in. And you may have noticed that tags come in kind of 3 different flavors. They're either there or they're not. That's called a marker tag. Think of that as like a checkbox. There is property tags, which means there's a name and a value pair. Area is 10,000. The weather is Golden Valley. And then there are reference tags. So this point is part of this piece of equipment that happens to be an electric meter, and this electric meter is on the vehicle testing something facility over at NREL. That's where they test electric cars and batteries and cool stuff like that. Awesome. And so in this case, we're seeing 2 or 3 reference tags. There's a site reference tag. In both cases, these records have it. This one has an equipment reference pointing back to that. And so in the days of creating databases, these would be relational database tables. In Project Haystack, it's just a flat database, but you can have infinite number of relationships by just putting a special tag with the REF and then a name of a record. Actually not a name, but a tag for a type of record that you want to reference. Getting a little bit deeper, there might be a chiller ref, a boiler ref, electrical panel ref. Where am I getting my hot water? Where am I getting my chill water? Where am I getting my electric from? In this case, this is where I'm getting my air from. Cool. So that's the essence. You now have all the working knowledge to work with tagging and metadata. You have some specific syntax that goes along with Project Haystack. And really the only other additional concept is this idea of data modeling. So the big payoff here is that if I were to take those points and put them into a model, a template if you will, that's what data modeling is. It's the idea that on a bigger view of things, I'm dealing with, let's say, an air handler or a chiller, and it's made up of a discharge air sensor, a mixed air sensor, a fan command, and a hot water valve command. And when you start getting into the practical application, you'll see that this data modeling really pays off from an engineering best practices standpoint, or better said, if you have engineering best practices, the payoff will be that much better. Because now you can teach an application to do the same thing over and over again if there's any typicalness, and it happens in an instant. And I'll give some examples of that. So you can have tagging at the point level. You can have tagging also at a higher level, which would be at the equipment level. And by modeling VAV type 1 and air handler type 2, you can get huge payoffs of reusability and things that just automatically work. So let's get into the real world. If we, in a perfect world, fast forward hopefully 5 years, I don't know how long this will take, but just imagine a world where all of the inputs and all of the outputs, the people that need that information, and all of the applications that are doing cool stuff are all based on tagging. And that means that you might have a guy working out of his garage that came out with the most killer mobile experience you've ever seen because he was creative and he had the right tools. He could, through tags, have half of that equation, and the owner's site would have the other half, and it would be seamlessly, it would just work starting day one. And so there's very little barrier to entry for innovation. You don't have to wait for the big manufacturer to come out with their next release, which only has one of those cool features, and it's not quite as cool as you thought it would be. So this is the holy grail that we're pitching, is that any application, any device would magically be able to connect to itself and other applications so that you could pick the best of breed, and there would be a rapid innovation opportunity. That's exactly the combination of the protocol and the data model. Yes. So the protocol is what's going on the wire between that cool mobile device and, let's say, the Jace or the Commander BX or ... And then the standard tagging is that this mobile app knows to put up a thermostat visualization without you drawing it, because there was a tag on a data model called thermostat, as an example. All right, so let's give you some real life examples. This is the takeaway of what I would say is the holy grail for us in the BAS or smart building space. Let's start with a high level one. The easiest one to talk about is user experience. What do I want in my user experience? I want it to run anywhere, tablet, desktop, smartphone. I would like to have it for different audiences, maybe different users. When they log in, it will figure out who they are and give a different graphic, because now it's easy to do multiple graphics. There's not a ton of labor. Normally you're just going to do one size fits all because that's all you're getting paid for. But what if this application could figure out what the different audiences are, and because it's auto-generating the graphic, you could have 5 different graphics for 5 different audiences. The data is not bound by a system integrator going link, 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 link. It's being bound by a query. And so that query enables that automatic process to happen. And so automatic graphic creation is exactly what's going on in Commander. So how many of you guys have seen the Commander cards? That is the user experience for KMC Commander. And behind the scenes, you didn't have to engineer those, right? You just basically discovered the device, and because of tagging and data modeling, it automatically bound to the user experience. Great example. So there it is. Instead of being a card, this might be a full-blown air handler. The idea is that we would have that one-to-many relationship potential as well. And so we'd have these tags on the graphic template. We'd have the tags down in our database on the points. And it's really like a matching game. Everybody gets into the room when I pull up this graphic, and if this template out there sees that there are matching set of tags for all the points, it automatically populates them here, here, and here. How do you do that today? I know I was called a link monkey in my office. My job was to go link, 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 link to make all those air handlers work. Now the good news is with modern software, you can have relativized graphics. Everybody know what that term means? You make one template and then you get 15 or 1,500 graphics. But it's a step in the right direction, but it's happening now even more efficiently because of tagging and data modeling. What about automatically generated? So this would be the equivalent of KMC cards, where there wasn't a template. It was literally hard-coded, if you will, by the application. And some really neat things happen. So behind the scenes, you would have a typical VAV. You would have tag data down in your database, same story as we had on the previous slide. But some other things can actually happen too. In this case, the application made a few decisions for us where the system integrator would normally have to do those by hand. One of those decisions might be not only displaying the name, the value, and the status, but in that database record, there might be a tag called HIS, which is short for history. And the application's like, oh, I know. Every time I see that tag, I'm going to put a button on this graphic, and I'm going to hyperlink that button to the history for that particular point. And so you didn't have to think about it. The application took care of it. Another example, this one is tied to a tag called writable. And what would happen if you push that button? You'd get your commands, emergency override, manual override, or auto it. And this one's a schedule object. And I think that one is looking for a schedref, a reference tag called schedule ref. But when it sees that, it makes a hyperlink to another application. Instead of a pop-up, it's linking you over to the schedule editor. And I think there's one other cool thing that goes on. Oh, yeah, these icons are in a library, and the application says, hey, I saw, let's see, what is that? Airflow and sensor. And anytime I see those 3 tags in combination, I'm going to reach into the library and stick a little airflow sensor there. Now, don't get me wrong, this is sometimes scares people because they're like, wait a minute, what if I screwed up one of those tags? And most of the software will degrade nicely. So in this case, if I didn't really have an airflow sensor, I just grabbed the data right out of BACnet or grabbed it right out of Niagara, this would degrade nicely. You'd still see airflow, which is the display name. You'd still see the value. If it had history, it's still there. But instead of being a fancy airflow sensor, it might be, let's see, that's a numeric value. So I think it's purple, and it has a little arrow because it's an input. So it would interpret down at a little bit lower level that it's an input and it's numeric and draw an icon for that. So it's not all or nothing. There's different gradients of payoff that you get with tagging. So don't get too nervous about getting it perfect. All right. This is the one that leverages reference tags. So remember, the relationship tag that this VAV is getting its error from error handler 1 is in each of the equipment records for the VAVs. So this particular application, as an example, would look at those relationships, run a query against all pieces of equipment. It would resolve a little list of VAV 1 through 10, and then it would dive down into each of those VAVs and iterate the equipment name, the damper position, the OC mode, That's exactly what KMC Cards does as well on the opening screen. It looks at the list of devices, generates a visualization, and then you drill down to the cards to get the individual lines. This is all based on queries. So what's one of the fringe benefits of being a query? Well, if you have a technician working out in the field and he just brings on VAV 11 through 15, quite literally the next time I refresh this browser with never going into the graphics editor and the traditional adding things to the database, just by those things coming online and this being based on a query that's looking for a reference tag back to error handler 1, you'll see VAV 11 through 15. It's all dynamic. If I were to delete one, it would not be there the next time, that kind of stuff. So one of the most amazing things that I've experienced is during our training class, we'll do a typical project that has multiple buildings. And towards the end of the class, we might be up to maybe a couple air handlers, a bunch of VAVs, and a boiler plant. And we go in and inhale that third building. And then people just happen to wander out back to their graphics. And they're like, wait a minute, that site's now there. And then they'll dive down in. They're like, wait a minute, the navigation's there to floor 1. There's no floor 1 graphic, but I can see that underneath that tree, there's VAV 1 through 15. And there's graphics for those VAVs because they happen to be typical. And there's summaries because they happen to be tagged similarly. And so essentially, they see that whole new building online minus the floor plan in a split second. It's really, really cool. All right, command and control. What if we take this idea one step beyond the visual, beyond the user experience? What if we start talking about DDC control, supervisory control, maybe even demand response, higher level controls? We want to be able to abstract these control strategies so they're not vendor specific. We want to make them flexible. We want them to be standardized, so best practices not only in graphics but in control strategies. Where I'm going with this is we're going to see that relativized graphic concept apply to control routines. So imagine being able to create one control strategy for, let's say, set point reset, and then have it automatically bind to as many VAVs or as many rooftops that need the set point reset algorithm applied to them. So give you a live example. This is maybe the blocks that go into creating the routine. If I was doing this yesterday as opposed to today, I would highlight all these, copy, and then go to another page for the next VAV and paste them. And then I would go link, 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 link to the inputs and the outputs that are specific to VAV2 instead of VAV1 where I copied it from. And then I'd do that the third time, the fourth time, by the 10th time I'd shoot myself. I'm here to say that the concept of having that sequence of operation or control routine can leverage tags just like graphics do. The control routine application uses that same concept, and I can create one routine, and as soon as I save it, it goes out and through queries binds itself to as many VAVs that it finds that need the matching set of tags. Way cool. What does that mean for end users? What does that mean for system integrators? Well, for system integrators, installed cost is going to come down. Your labor is going to come down. You'll be able to do more, better things. For end users, it gives them the ability to say, what if? And prototype things. You know, if I had a big facility with hundreds of things, I would get a big quote in order to try something, and I wouldn't do it because it would be too cost prohibitive. With this relativized control strategy, I could come up with a really cool idea and say, let me try to do a new twist on morning warm-up because I know the sun on that side of the building is blah, 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 blah. And literally I would add a tag to this sequence, save it, and tomorrow it would be implemented on the west side of the building based on that one-to-many relationship. So you get a faster ROI for hypothetical ideas that would normally be too expensive to try out. That's just one great example. What if we go one step further? Remember, we've heard about analytics. So we talked about user experience. We've talked about an example of command and control. What about analysis, analytics? Well, instead of a control engine, just substitute the idea of a rules engine. How many of you guys know what analytics is? You guys, okay. In my simplified version of it, it's kind of what we already do today with real-time data inside a control engine, but it's more appropriately looking at historical data in a rules engine and then putting together the conditions that I'm looking for. So a classic example would be simultaneous heating and cooling. Just like we saw in the control strategy, I might have some series of blocks or line code that looks at some inputs like the hot water valve and the chill water valve, and then the output would be I am simultaneous heating and cooling because my hot water valve is above 0 and my chill water valve is above 0. That's a rule. Okay? The difference, like I said, is oftentimes it's applied against historical data, but this part of the equation is exactly the same. The rule engine can have a rule one time, but then could apply itself through the magic of automatically binding using tags to as many histories that are required to cover all the air handlers or cover all the rooftops or what have you. And then you might get a visualization of 4 or 5 rules and when the rules were broken. So there's our simultaneous heating and cooling. Here's a short cycling. Here's the air handler was running when it wasn't supposed to be. Here's a cooling failure. And then behind the scenes there'd be a set of rules. Cool. So that's the hope. And then there's plenty of other applications that haven't even been invented yet, that once you know that the fundamental labor to do that connectivity is gone, it's going to breed more innovative things, more services like we saw yesterday. So I've seen system integrators come up to my booth and they're like, I got this great idea. I'm like, oh, I know what he's going to say. I'm going to get into the services business. I'm like, well, let's talk, because I have a great way to take your idea and hook it to the real world and start making services work. Companies like Intel and Dell really learned a lot about our world and how messy it is over the last 2 or 3 years. You know, they were so pie-eyed going, we're just going to connect to the building. And we're like, do you know how to tune a loop? Do you know what a snippet is? And they're like, no. I said, well, it's a mess down here, so just hold on. We'll make it a little bit easier through great things like Commander. But yeah, so this is really the tip of the iceberg of cool things to come. All right, so to wrap it up, it's really a collaboration effort. It's a community effort. Project Haystack is just a bunch of guys and gals that got together and said, there's got to be a better way. And there's a nice open source website. There's reference documentation for the spec. We'll get into the details of what's available for resources. But basically the concept is open standards and data modeling are going to be the glue that enables all of this innovation. It's going to provide options. So both as a system integrator, you'll get to choose which devices and tools that are going to serve your customers the best for end users. It's going to let them buy the best of breed. You've probably heard this story before when we were talking about LawnWorks. But it really is delivering at a higher level, the applications, not just the devices talking to devices. And I think that's why that graphic on the interoperability was so key, because it shows that we've gone to a higher level and a wider story. You know, the reality is that new solutions and services are going to be more rapidly available, and the industry as a whole is going to evolve faster together. Awesome. So at this point, I can switch over to the other screen for Q&A. Basically, a lot of the things that you might have a need to ask, I've tried to pick the top 5. And so first one is, let me ask you guys if you have any questions from the slide deck first. Or I'll just dive into my, my seated example. Okay. Did you know that's what speakers do? Even though there's a Q&A session, they'll always have like 2 in their back pocket. Watch a webinar the next time and you'll find that that's true. Anyways, how do I find out more about Haystack and how it unlocks these things? Give me kind of a high-level marketing piece. Well, if you go to the download section at Project Haystack, it's project-haystack.org. Under the download section, we have a really wonderful magazine that comes out twice a year. We're trying to do it even more often. And I think we go back 3 years. And what that does is it shows case studies. It's got vendor product advertisements, which is a good thing. You get to see who's got what. It's got some technical discussions. It's kind of the whole community piece in a single magazine. It's a good light read. It's not too heavy like a white paper or getting into the actual website. So recommend going to Haystack Connections magazine. And we might have the author among us. Is that true? This is Therese. She actually does all that wonderful work, collecting the information from the community throughout the year and publishes it both in a PDF and in an e-zine format with all the good hyperlinks in it, which I actually like that a lot. All right, so where are all these magical tags and data models documented? Project Haystack under Docs. So if you start here, it's a little bit more of a bit of a read, but if you start in Docs, you get the high level of what I've talked about with some more detail. And if you go into tags, that's where you'll actually start to see some of the concepts reach fruition. So let me just give you an example of a tag for an air handler or a piece of equipment like an air handler. You can just do a search. They're all arranged alphabetically. And so if I was building my database right today, the fundamental concept behind the software or the tools would be that the record that I'm going to drop in there is going to need a tag called AHU. And so this is kind of a little bit of a litany of what an air handler is to the group. This is maybe a tag that we could add to it. If it's a rooftop, that's a specialized case. So a bunch of people said, hey, let's come up with a rooftop tag. And so you can combine tags together to create more clarity. Unlike a naming convention where you always have to get a longer and longer name, the tags can stand alone by themselves. So you could have a AHU and rooftop tag on this particular record, and it would then be searchable by an application like KMC Commander, and it would auto-generate a card as an example. Cool. So that's our docs and our tags. What if you're a developer? What if you're that guy with that really great mobile app in your garage and you want to participate in this community? Well, that's where you go to the download section. There's code examples for the API that I shared about. Remember, there's a protocol and a standard. So you already got the standard figured out, and now you want to code the communications between your mobile app and a box of some sort. You can go there and download. I think there's a Java version of it, and what's the other one? There's 2 reference designs under the hood. We can go there. It's in Bitbucket. Let's take a look. Downloads. And we'll scroll down just a bit. There's the specification I was talking about. It's also available in French and Chinese. Who knew? There's our logo, there's our resources. A couple of great videos. One specifically on Haystack, a couple intro videos. Okay, so there's the Java toolkit, and there's a C++ version of it right here, or C# as well. I remember reading about that in a magazine. Yeah, the resources page, exactly right. All right. And so you could literally go to this website for free, download. There's no fees. You can become an associate member for a small fee. That's more of a marketing decision than it is getting access to information. This is all open source. You can take those reference designs and extend them and do all sorts of good stuff. So what if you have more questions? Is there a community that can help me? And the answer is yes. There's a very vibrant forum, and I believe developers really appreciate this because they can go in and start a conversation in the forum, And just like a typical forum, it's chronological, and then people can comment on something. And then if enough people get interested in it, we just came up with this idea of a working group, not too different from a ASHRAE working group, but maybe a little bit less political and more efficient. So I didn't want to have a negative connotation to a working group. So currently there's a bunch of guys here that care about this working group that has to do with a reference model. And basically they're talking about a best practice for something. And so there's the ongoing discussion about it. And they'll get together virtually, maybe once a month or whatever the urgency is, and you'll see that expand into getting published into the standard. Awesome. Well, that's great. Can I contribute? Yes, you can. Certainly beyond just doing the forum would be going to a working group. But what if you do finally take that API and make that killer mobile interface? What's the commercialization aspects of that? Well, independent of projecthaystack.org is a website called StackHub. And technically, I think that should be .com, but call me silly. It is the commercial version of the organization. And the idea is it's fundamentally a repository, so it's got version control for code. It has user privileges, which means that KMC, as a OEM, could create a company, and each of you could be underneath them, and only KMC dealers could see KMC stuff. There's even more granularity. You can create a company, and then your employees can then have privileges to, let's say, best practices for ABC controls. And then the other extreme of that is you could post a great idea there for free or for sale and not need any of those privileges. So it's a very multifaceted concept, and it's in the beginning stages, but just go to stackhub.org and you'll start to see certain aspects of the community and people that are contributing. I think there's a KMC, there's a J2 Innovations, there's rules engines, there's all sorts of good stuff there.